Good morning, everybody. Welcome to my tutorial on Introduction to DHCP and User Options, also known as Plug and Play. My name is Terrell Boyer, and I wanted to thank you for your time this morning. If you find my content interesting and would like to see some of the other videos I've done, you can either go to my YouTube channel or subscribe. You can also go to my website, which is ineedvoip.support. And on the website, I've kind of got it laid out in a way that I've got the advanced topics in one area, and I've got the beginner topics in another area. So if you're more of a beginner in telecom, then there's some useful videos there, some of which are some of the other people on YouTube that make good content videos for our industry. So. Okay, with that being said, let's dive into DHCP and user options. So the first thing to know about DHCP is what exactly is the application for DHCP. Why do people use it? And what DHCP does is it allows the network administrator to create a predetermined pool of IP addresses that if a guest comes into the network, they can plug into the network and they can get an IP address and a certain amount of information about the network that will allow a device to communicate on that network. Now, there's different security pieces that you can put around it so that only certain people get IP addresses. But for the telecom tech, which, as you guys know, if you've watched any of my other videos, my background is telecom, and most of the IT contents used to. Telecom and IT were two completely separate fields, and they didn't cross paths. But lately, with voice over IP, they're constantly crossing paths, and it's hard to tell sometimes the difference between a VoIP technician and an IT technician, because we both have to know. A VoIP technician has to know everything about the phone system they're installing, plus they have to know everything about the data network that they're installing in. And so my videos are geared towards helping the telecom technician come into the VoIP world and understand the network environment that they're installing in. So with that being said, this video is kind of geared towards the ability to deploy IP phones in an environment that requires that you've got a lot of IP phones that you're distributing, but you don't want to go around and manually configure each one of those IP phones. So there's a feature called Plug and Play that will basically allow you to plug the phone into the jack, and if your DHCP scope is set up properly, then if the DHCP scope is set up properly, then it will hand back the information that phone needs to register. And so whoever's deploying the phones, all they've got to worry about doing is plugging it into the device or plugging it into the phone. And it also works really well if you've got a large campus, if you just, or maybe a campus that expands multiple offices. You can have one telecom administrator centrally located, let's say in Dallas, Texas. And if they're servicing an office in California or an office in Florida, then they can actually program all the configs in the phone system, and then they can call the IT guy down in that particular area and say, hey, go grab a phone out of the storage closet and take it, let me know what the MAC address is, and take it to this user and plug it in for them. And so, for an administrator, it makes it really easy because you don't have to depend on people on the remote sites to do any programming. All they have to do is be able to read the MAC address off the phone and give it to you so that you can program it in your system to register. Okay, well, that's a bit of a long-winded introduction. So just real quick, this title slide, I put this together to kind of outline the areas that we're going to cover. But basically, we're going to cover the discover, the offer, the request, and the acknowledgement of the DHCP exchange. And then we're also going to cover like user option 43, for example, which is plug and play, and I'll kind of go into a little detail as to how that works. Okay, so that being said, I'm going to switch over to my lab computer. All right, here we go. So the first thing we're going to do is I'm going to go ahead and restart this capture here. So that we're starting with a blank environment. As I do with all my videos, I kind of run through the lab environment to make sure we've got the best chance of success of creating a successful video. So the first thing I want to do really is show you guys what a DHCP pool looks like from the router side. So so if you look here on my screen, and I'll zoom in, what we've got is you've got basically my router at my office, and within my office I'm running 1, 2, 3, 4, 5 different subnets. So basically this particular router is serving 5 different subnets on our network, and each one has slightly different parameters, but as you can see, I only have one subnet that has this code 43, which is what we're going to use for plug and play. So, what we have here is we've got basically I've identified which VLAN, so that when the request comes in, the VLAN will be tagged, and it'll say, okay, for VLAN 231, this is the pool that I need to offer. If the VLAN ID is 240, this is the pool that I need to offer. If the VLAN's 200, etc., etc. So the first thing that I hand out, and these are all configurable options that you can hand back to the phone, but the phone is going to be interested in my environment. My phones are going to be interested in a couple of key components, which is one is going to be the IP address assigned to the phone so that it can communicate on the network. The second piece is going to be the gateway or the router, so that if it can't find the device that it needs to talk to on the network, it'll go to the gateway address, which is our router, and it will send that traffic to the gateway address, and then the router will need to know from that point how to route it out to other networks. So that's the IP address, that's the gateway. The other piece is how big is the network. It'll need to know the subnet mask. So pretty much any device that communicates on a LAN WAN type network is going to need those 3 components. Now, the one additional component that we're offering out within this DHCP pool is going to be user option 43. And what this is the IP address of the phone system. So when the phone pulls down its IP address for itself, it's also pulling down the IP address of the phone system. Okay, so you can kind of see where we're headed with this. So within this DHCP pool, the other thing that's important to note is here I identify the network that the DHCP scope's going to be within. So by default, if I just left it right there, it would start handing out any available IP address within this network. So in order to avoid that, I have to include an exclude range. You never really want to, or at least I've never really wanted to hand out every single possible IP address in a range. I always save, depending on how many devices I have, at least 10 to 20 static addresses for things like servers or switches or just a PC that I may need to get to on that particular subnet. So I keep about 10 to 20 addresses available for static assignment. So I'll create an exclude range of anywhere between 20 and 100. So basically here I've blocked out let me go up here. I've blocked out 231.1, which is going to be my router address, all the way through 99, just in case I want to add static devices to that particular network. So basically, the router will pick up and start handing out IP addresses at .100. So, and real quick, just so you can kind of get an idea of how many So what I'm going to show you here is just kind of how many IP addresses are handed out off this particular router. So right now I don't have that many because it's Saturday morning. Most people have shut their laptops down, so most of these will be IP phones and stuff like that are connected here. But what you're looking at is a list of the router has kept up with the list of all the IP addresses that it's handed out. So you can see all the different subnets have been handed out. Like 231 is my voice network, 250 is my PC network, 230 is another voice network for a different system. I forget what 240 is at this point, but anyway, so you can kind of see that these the router keeps a table of all the IP addresses that it hands out, and none of these will be within that exclude range that we were looking at previously. Keeps a list of the MAC addresses. That's how it identifies who it's given the IP address to. And then the other thing is the lease time. Basically, this is how long the device and the IP address is lended to that particular device. Because if that device leaves the network and for whatever reason it doesn't release that IP address, then when this timer expires, if it doesn't re-request the IP address, that address will go back into the pool of IP addresses to be available for somebody else to use. Okay. So that kind of covers that piece. So let's jump in, and what I'm going to do is I'm going to reset an IP phone on the network, and we're going to watch the traffic here from that particular phone, and then we'll go into to the packets a little bit. That phone's hanging off of my switch 3, so I log in here. Oops. And I've got a little bitty keyboard at home. I keep typoing. And I love the ability to turn on and off PoE remotely. So what I just did there is on my Ethernet switch, it's a PoE Ethernet switch, and I just went in and killed the power to that port, which turned the phone off. And now I'm going to restore the power to that port that the phone's hanging off of. And real quick, while that phone's rebooting, let me make sure my trace is going. Yep, it's going. Earlier, I couldn't find out where the phone was, so within the switch, I'm sure you guys know this already, there's a MAC address table. And so I was able to... okay, it's not finding it right now because I killed the power on it, but... I can go and see which MAC addresses are off which port. So I actually logged into the phone system, and then I went and found the MAC address. So I can go here and go, okay, there's my MAC address. It's E1BF, and then I went back to my switch, and let me quit that. And I looked down here until I found E1BF MAC address, told me it was off of port 19. And then I could go in and kill the power to that particular port and then re-enable the power to that port just to reset the phone. And I'm running Wireshark so that we can see the DHCP packets. So let's jump here. We're going to go ahead and stop this trace. So every, not every DHCP exchange, but most common DHCP exchanges, you'll see this pattern, which is discover, offer, request, and acknowledge. Those are the 4 most common messages you'll see in the DHCP exchange. The discover message is, you'll notice over here, it's sent to a broadcast address. And basically when you plug the device into the network, it sends out a broadcast message to the entire network. When you see this 255 all the way across, that basically says broadcast this packet to every device on the network, whether they're on a switch, a hub, no matter what. Every IP address on the network, please, broadcast this message. And what it is it's the way it's coded is it's a discover message. It's saying, are there any DHCP servers on the network? And here you can see that 231.1, which is my network's DHCP server, responded and said, yes, I'm here. And I do have an IP address that I can offer you. Just real quick, within Wireshark, if you want to see only DHCP messages, you can type in boot P for boot parameters. And that'll filter down. You can see I've got 8,000 packets in this trace, but I'm only displaying 7. One, because I filtered by the IP phone, but even further to filter down the traffic, I added boot P to that. So I'm only looking at DHCP traffic from this one particular IP phone in this request. So the Discover packet, we'll kind of dive in here real quick. Looks like this. If you go to the Bootstrap protocol line here, you'll see right now the client IP address is 0.0.0.0.0. If we go down through here, these options are how basically if you look in the router side, which we'll do real quick look in the router because it's information overload for DHCP looking at the router side of this. But everything's configured as options. Option 53 is what type of message is this? It's an offer message. Actually, here's the Discover message. Discover, everything's zeroed out. And this is useful to know that I've found and actually learned this making this video, so I'll use this in the future. If I don't know if a particular device supports plug and play, or if I don't know every parameter that can be configured by plug and play for that device, looking at this Discover message, my assumption is that the device, which is an IP phone in this case, is asking for all of this information. And so my expectation is that if it's asking for this information, that if I configure this information in the router, it'll actually configure itself with this information. So there's a lot more there than I was aware of. I was aware of user option 43, but it looks like you can actually program NTP servers, domain servers, static routes, router discovery. So you can do, and some of these options may be enable, disable, as opposed to providing like a full IP address. But I have plans in the future, and maybe I'll do a follow-up video to go through and do some research on each of these options to see if there's anything else that I can be assigning to that IP phone that may be helpful for an installation. And I would also expect if I plugged in something like a webcam to the network, an IP webcam, that I'm not familiar with and I may not have documentation or access to documentation, I can plug it in, monitor the traffic, look at the DHCP Discover, and see what kind of parameters it will take. If that particular camera needed to go back to some kind of server for monitoring, maybe it has a parameter in here that would allow me to do that. So I'll use that for troubleshooting in the future. You guys may want to do so as well. So again, first packet is Discover. It's the device saying, please give me, is there a DHCP server on the network? DHCP server responds back and says, yes, I'm here, and I have this IP address available. Then it's up to the device. The device has to officially request that IP address, or at this point it can say, no, I don't want that IP address. I've never actually seen that happen, but I'm sure there's, looking at the RFC for DHCP, that option is available, so there's got to be a scenario out there where the device says, nope, that address isn't going to work for me. And then the final phase is that the DHCP server will acknowledge the request, and basically at that point the lease time is expired, and there won't be any more chatter until either the device sends a release message or the lease expires, and then the DHCP server will inform the device that the lease is expired, or the device will request a new DHCP address at that time, and it may even request the same IP address. Okay, so Discover offer. So after the Discover, the DHCP server offers back an IP address of 231.103, and the other information that it offers is the That's the DHCP server address, but it offers the subnet mask. And then down here it assigns the router. So I could actually have a DHCP server that was .50 but still assign a router of .1. So the DHCP server and the router don't have to be one and the same. They can be two different devices. And this IP address here, in my scenario, they're actually one and the same, so that's why you see the same IP address here. The other thing that I'm passing out is DNS server 8.8.8.8. Not that my phone has any use for a DNS server, because everything that it needs is on the local network. It's not going to be resolving domain names. But for me, it's habit to put a DNS server within the DHCP scope. But if you wanted to create a network environment where you didn't want people to really be able to browse the internet that easily, then one thing you may do is elect not to distribute the DNS server. And what that means is when they type in google.com, it won't resolve, it won't have a DNS server available in the IP information that it was handed via DHCP. So they'll think that they can't get to the internet on that particular connection. It's kind of an easy deterrent. Now, if they have any bit of knowledge, then they'll try to ping an IP address and see if they can get to that. And if they do, they know they've got a route to the internet, and then they can manually assign a DHCP. But that's probably something I would do. But if you've got an average user coming in that just sits down and says, oh, there's a network chat, maybe I can get internet out of it, they're not going to know to do all that, and they're going to plug in and they'll get the impression, hey, there's no network available here. So that's an easy way to keep people off your voice network, is if your phones don't require it, don't hand out a DNS server. Okay, so that's pretty much it, with the exception of the plug and play option. So the way this works is I've programmed in the IP address of my phone system, and so now the phone has all the information it needs to communicate on the network, and it has and it has the IP address of the phone system, if you see it down here at the bottom. So it knows who to go talk to next. And as you can see up here, if I scroll up just a little bit, we can see the MAC address of the phone, which is that E1BF. And so if I have this MAC address programmed in the phone system and the phone knows how to communicate with the system, now we've got all the information we need to do an authentication. Because what'll happen is the phone will say, now it'll reach out to the phone system with a registration request and say, I'd like to register. The phone system has a table of predetermined MAC addresses, and it says, your MAC address matches. I'm supposed to give you extension 2001. Here you go, and the phone's registered. So there was no having to go into the phone and say, here's my server IP, here's my username, and here's my password. And I know it doesn't seem like a whole lot on one phone, but if you're rolling out 1,500 phones, then that amount of time to go in and type in the IP address, the subnet, the gateway, the server IP address, the username, and the password takes a lot of time when you multiply that out times 1,500 devices that you're trying to roll out on a network. So I can spend a couple of hours setting up DHCP scopes and VLANs, and then I can get somebody to just go out and distribute the phones for me, and I control everything back from the switch side. And then if you've, like I said, if you're a big system administrator, then you can the only thing that you have to tell people when you give them a phone is, hey, if it's not registering, just default the phone, give them the process to do that, and then it'll probably register. So it comes in helpful there. Last thing that I wanted to show you guys is I just wanted to you to kind of see the router side of a DHCP request. So what we're going to do is we're going to log into my router here. And we're going to do debug IP, oops, not debug up, debug IP, DHCP, and we're going to do all, and then we'll do debug terminal to let it know where to display this information. And like I said, this is going to be information overload. So I'm going to go back over to my switch, and we're going to go admin, put in the secret password, and you're going to go configure. Turn off the power for that phone. Turn on the power for that phone to reset it. Then we'll go over here and watch the router. Now we'll probably see, because this router's serving all those other devices, we'll probably see, some leases expiring and stuff like that. Hopefully, since it's the weekend, we'll only see the traffic for this phone. Let's watch Wireshark here just to get an idea of when it comes through. This is in the 230 subnet, so this isn't what we need. Oh, there we go. So we're going to go ahead and kill this. And we're going to kill this capture. Okay. So now, if we go and look, here's a discover received, and it's got the MAC address for, that's not the phone. That's going to be the MAC address for that particular interface. Here's the MAC address for the phone, which is E1BF. And so it says, okay, here's a discover request, and here's all the information that it's trying to discover. The next thing that you will see is going to be an offer request, which is it's going to be handing back that information or giving it a particular IP address out of that subnet. That's available, the next one that's available. And if I look here very closely, we should see like an ICMP packet. Don't see it. Sometimes what you'll see is that the DHCP server will actually ping that IP address just as a second acknowledgement that IP address is available before it hands it out. Here it is up here. ICMP echo sending to 231.103. So it sent out a quick ping just to make sure that nothing responds immediately, and then it hands that IP address back. And then, down here at the end, the last thing that you'll see is that acknowledgement saying, okay, I've got it. And so at that point, it's assigned. So you can see also here in the offer message, you'll see all the different parameters that were requested, but you'll also see what was sent. So requested parameter router, sending router, requested parameter DNS server, sending DNS server. And then it requested all this, but we didn't have anything to send. So if you're debugging DHCP and you see the request but you don't see a send, you may need to go back and look at your DHCP scope and determine if you actually have that parameter programmed or not. So, all right, guys. This is a lot of information on DHCP and plug and play, but you guys signed up for it because that's exactly what the title of the video said. Let me go back to this screen here, and I'm going to put a subscribe button on here for you guys. So if you find this kind of content useful, like I said, I gear my videos towards the VoIP technician. But a lot of the concepts that I cover could apply to an IT technician or a voice technician. So, look at the content, look at my website, subscribe, leave me comments. I'm open to suggestions. I'm always interested in knowing what you guys need to know in the field, and I'll try to generate a video that'll help you out. Thanks a lot for your time today, and have a good weekend.